Hello student, welcome to my official YouTube channel Mathematics All Levels by Akif Khan. So today the paper which I have taken is the modified version of Pure Mathematics 2 examination, which was conducted 4 days after the paper 2 examination. So again, I'd like to say that this video was created for the only for educational and instructional purpose. No need to create the no need, not intended for the pre-production or redistribution of the examination paper. So this is the modified version of this paper 2 examination. So let's solve it. So I've taken all the questions on its on a PowerPoint. So the first question here states that we need to state the coordinate of P. So here we can see that we need to find the coordinates of the P. So it's very easy, by the way, but I'll tell you in detail that mod of x negative of 4 plus 10. So this mod value, just we need to substitute equals to 0. It's just an explanatory part. You need not to do this part. I'm just explaining you here. So x is equals to 4, so it will be shifted towards right. So this is the right part, right on the x-axis. So this is 4, the x point will be 4, and the y point, you can see here that this part x negative 4 is in the modulus and plus 10. So if we consider this whole as x and this plus 10, so it will be equals to y. So what we can observe from here, that we need to shift the y coordinate up towards in the graph by 10 points. You can see here. So it is 10 points above the graph. So what will be the coordinate of P, students? That will be 4 comma 10. Okay. So this is the coordinate of P. Now second part, they have asked that we need to solve this equation that modulus of x negative 4 plus 10 equals to 3x. So I'll solve it here for you. First, what we need to do, mod of x negative of 4. It will have two behaviors. First, it will be x negative of 4 when x is greater than 0. And it will be negative of x negative of 4 when x is less than 0. Okay, means it will have a positive value and negative value. So if I take the first part, that is the positive part, so what we'll get? We'll get x negative of 4 plus of 10 equals to 3x. Okay. So if we calculate it from here, what we'll get 6 equals to 2x. So from here we can say that x will be equals to 3. X will be equals to 3. And you can see here that we have got the value of x equals to 3 when we have taken the positive part. Now in the negative part, first I will solve it. In the negative part, we will substitute x negative of 4 with negative of x in the bracket negative 4. So it will be negative of x negative of 4 bracket plus of 10 equals to 3x. Okay. So we'll get negative of x plus of 4 equals to, not equals to, will be plus 10 equals to 3x. So here we can see that we're getting 14 equals to 4x. So the value of x is equals to 14 by 4. We can see here that we are getting the value nearly equals to 7 by 2. Now student, this is the method we have opted to solve this particular question. So we can see here that we have taken the positive part and the negative part. Now we need to see that what will be the solution for this question. So the solution for this question will be, I'll write it for you. This will be the solution, x equals to 7 by 2. Why is this so? Why I will not take x equals to 3? Because when x is equals to 3, and when we are substituting this value here in this equation, so it will be a negative value, means 3 negative of 4 will be equals to negative 1. So negative 1 in the modulus, but here we have taken that x is greater than 0. So that is why this answer could not be possible. This answer will be possible. So the exact solution, sorry, exact solution will be x equals to 7 by 2. Okay, the only solution for this, not this part. But in the working, you need to show, because the method counts and you will get for method and accuracy. So the part here is, for method you will score M1, and the accuracy part which we have scored here, that is A1. Okay, so this is how we need to do this question. Even some of the students can also solve it by squaring on both the sides. Just need to transpose 10 on the right hand side, and then we need to square it, and then after squaring we get the quadratic equation. From there we can get the value of x. Okay, now let's come to the next part. Yeah, in the second part, student, they have asked us to sketch the graph. Okay, before solving this question, I'd like to tell that I've already made a video of on the logarithmic and exponential function. So I've taken certain topics in that, and even as previous year questions for logarithmic and exponential functions. So here y is equals to 2 raised to the power negative 3x. So y will be equals to, it could be written as 1 by 2 raised to the power 3x. Sorry. So what we do, okay, the basic graph of this equation will be, those who don't know that I have already solved this video. So I've already taught this thing. So yeah, the basic equation of this function will be, it will pass through 0 comma 1. This is the graph, and it will go like this. It will go like this. It will not touch anywhere on the plus infinity fringe, and it will always pass through 0 comma 1. This I've already taught. So this is the logarithmic graph. So if this graph, exponential graph, passes from 0 comma 1, it means it will justify this value. So first point will be 0 and 1. Okay, this is the first point. Now let's say what will be the second point. So we can take any point of our choice. So if I say that take x equals to 1 by 3, okay, and plug the value of x equal to 1 by 3 here. So what we will get, the value of y will be equals to 1 by 2. That will be equals to 1 by 2. Okay, now what we need to do, we can take one more value here, that is x equals to 1. So we'll get the y value equals to 1 by 8. Okay, so if we plot this value on a, yeah, we plot this value. So this is 0 comma 1 in case if I say, okay, I'll not take that point as 0 comma 1. I'll take this point as 0 comma 1. Let's say that this is the 0 comma 1 point from which the graph will pass, from which the line will pass. Now the second part is, the second point is x equals to 1 by 3 and y equals to 1 by 2. So x is equals to 1 by 3. So if I say that this is the 1, and so this will be 1 by 3 somewhere here, and 1 by 2 will be this part in the middle. Similarly, for x equals to 1 and y equals to 1 by 8, so we can see that this value getting reduced when we are increasing the value of x. So somewhere here we can say, okay, so just what we need to do, we need to, this is how the graph will be made. I'm drawing as a rough graph here, so don't get confused. So this is how the graph will be going on. This is the one point and this is the one point. They just wanted to see your approach, that how you will be solving this part. If you'll solve like this, so then you will be able to score B1, because this is an independent question. In question number 2, if you see, question A part is independent and B part is independent. So then you will be able to score B1. Okay. Now the second part states that, student, we need to solve a particular equation, exponents and power. So it's a basic question, but I'll solve it. We can write it here: 32 as 2 raised to the power 5, and root 2 as equals to root 2, let it be 2 raised to the power 1 by 2. This could be written. So let's keep this part 2 raised to the power negative 3x. Here, applying the laws of exponent, so we will get 1 by 2 negative of 5. Okay, so what we'll get here? We'll get 2 raised to the power negative 3x equals to 2 raised to the power. We need to take the LCM and we'll get negative of 9 by 2. Now we can see the bases here are, students, similar. So the power here will be the exponents, the powers here will be also same. So it will be equals to negative of 3x will be equals to negative of 9 by 2. Okay, so from here we can say x will be equals to 3 by 2. Okay, students, this is how we need to solve it, and for this also you will be able to get B1 marks. Why B1? Because this is an independent part, as we have discussed. And now let's move to the third question, students. Yeah, the sequences of term a1 comma a2 comma a3 is defined by, they have given a particular sequences for us, and even they have given a particular relation, and we need to find the value of a key. Okay, just see that this is a1. What will happen if we substitute n equals to 1 in this equation? So we'll get n a2 equals to k a1 plus of 3. So k a1, okay, we don't have the value of a2 as well, and k also we don't have. a1 we got as 4 plus of 3. So this is the value of a2. Similarly, if we plug in the value of n equals to 2 in this equation, so for n equals to 2, a3 will be equals to k a2 plus of 3. Okay, now what we need to do, k a2 will be plugging the value of a2 from here. So it will be 4k plus of 3 plus of 3, that will be equals to a3. Okay. So a3 will be equals to 4k square plus of 3k plus of 3. So we have got a quadratic equation here, student. Okay, we have got the values of a1, a2 and a3. Okay, so now let's come to the relation which they have given in the question, that summation of an, where n is lying from, where n varies from 1 to 3, so equals to 12. So what does it mean? This means that a1 plus of a2 plus of a3 will be equals to 12. Okay, just we need to plug the value of n equals to 1, 2, 3, and it is a summation sign, just so we need to add this part. So it will be 4 plus of 4k plus of 3 plus of 4k square plus of 3k plus of 3 equals to 12. Okay, so yeah, okay, so yeah, just we need to solve it. So it will be 4k square plus of 7k plus of plus 10 equals to 12, which on further solving will get 4k square plus of 7k negative of 2 equals to 0. Now here we can factorize this part equation. So after factorizing it, we are getting 4k negative of 1 cross of k plus of 2 equals to 0. How we have factorized? Just multiply the coefficient of the leading term with the constant term. So 4 cross 2 will be 8, and we need to plug in the value. We need to make the product of 8 in such a way that we'll get the 7. If we don't want to do the factorization, you can also apply that quadratic equation formula here. From here, what we can see, 4k negative of 1 cross of k plus of 2 equals to 0. We'll be solving it here, students. So what we'll get, 4k negative of 1 will be equals to 0, and k plus of 2 will be equals to 0. From here, we'll get k equals to 1 by 4 and k equals to negative of 2. Okay? K equals to negative of 2. Now what we need to see, that what will be the possible value of k here. Okay, what will be the possible value of k here? So if I say, if I substitute k equals to 1 by 4 in this, the value of a2, so what will get, a2 equals to 4. Okay, if we are substituting k equals to 1 by 4, okay, I'll change my pen here. If I'm substituting k equals to 1 by 4 in this equation, so we are getting a2 equals to 4. Similarly, if I substitute the value of k equals to 1 by 4 in this equation for a3, if I say, so we'll get 1 by 4 cross of 4 plus of 3. So we can say that we are getting 4. Okay, again 4 we are getting. Okay, and even they have given in the question that it is equals to 4. So we can say that a1 is 4, a2 also we are getting 4, and a3 also we are getting 4 on plugging the value of k equals to 4, 1 by 4. Now in the second part, they have mentioned in the question itself that all the sequences are different. So if we are using this value of k equals to 1 by 4, so we are getting the same value for all the terms. So that is why this value will not be taken and this value will be taken. This is the correct solution of this question. K equals to negative 2. Okay, one more thing, students, that we will get the marks for the attempt, means for our approach here. So this is M1, means this is how we will be scoring the marks. This will lead to get the score, and once you have taken the correct approach, afterwards we will get all the marks dependent on the marks on the mark M1. So this will score, this will get you a score of D M1, and similarly this will get you a score of DD M1. Okay, because this is dependent. So hope I am able to satisfy you guys. So let's move ahead. Yeah, now the next question they have taken is so we need to show a sketch of the curve with the equation y equals to fx, where fx is equals to 2 raised to the power x negative of 10x. Okay. Show that alpha lies in the interval. Okay. Let's do the first part, student. We need to show that alpha lies in the interval 5, 6. So for fx, they have given a certain value, this function, that is 2 raised to the power x negative of 10x. Now, if I say that if an alpha lies in the interval 5, 6, which is including on both the numbers, so if I plug f5, x equals to f5, so what we'll get, 2 raised to the power 5 negative of 10 cross 5. So we'll get 32 negative of 50. We are getting negative of 18. Similarly for f6, if I plug in the value, So we'll get 2 raised to the power 6 negative of 10 cross of 6, 60. Now 32 cross of 2 will be 64 negative of 60, that will be equals to 4. So here we can say that on plugging the value of on plugging the values of the numbers which is given in the set, that is 5 and 6, we are getting ones as a negative number and one as a positive number. So here we can see that there is the change of a sign. Okay, so we know that if there is a change of sign, so the function is continuous and that alpha will definitely lies in the given interval. Okay, so we will write it directly that here the sign is getting changed, so we'll be getting the alpha will definitely lies in this particular means interval. Now in the second part they have given that f prime f x is equals to p cross of 2 raised to the power x negative 10. So fx, they have given us the function 2 raised to the power x negative of 10x. F prime x will be equals to 2 raised to the power x log of 2. This is the differentiation, negative of 10. Even I have made the complete playlist on the differentiation part, so you can have the access of that too. So we need to state the value of the constant p. Okay, p cross of 2x they have given in the question itself, so here we can say the value of p will be equals to log of 2. Okay, now in the next part they have asked us to for the approximation to alpha, that is to apply the Newton-Raphson method once the fx to obtain a second approximation to alpha. So we know that xn plus of 1, this is the Newton-Raphson formula, students. Xn plus of fx upon f prime of x. This is the Newton-Raphson method. So if I say, if we are plugging the value of n equals to 0, because they have given in the question itself that x not equals to 6. So for x, plugging the value of n equals to 0, we will get x1 equals to x naught plus of f x naught upon f prime of x naught. So x1 we don't know, will come here. X1 will be equals to x naught, they have given in the question, that is equals to 6. And fx naught, see fx naught in the question we need to write it, that what will be the function value of this part. So fx naught will be equals to, yeah, this was the number which we were talking about, fx naught. So on plugging this value we will be getting as x naught equals to 4. So fx naught will be equals to 4 on plugging the value of 6 in the particular equation I am talking about. We have just plugged in the value of 6 here. You are not getting my point, so I'll be writing it here. I have plugged in the value here, so we will be getting as 2 raised to the power 6 negative of 10 will be equals to 4. Okay, because in the question they have given the value of x naught equals to 6, so that is why we have plugged in the value here. So f6 will be equals to 4, so that will be equals to 4. And similarly f prime x naught, we need to plug in the value of x naught equals to 6 in the prime derivative of fx, that is this one. So this will be equals to, on plugging the value of 6 here, we'll get 64 log 2 negative of 10. So we'll write directly here 64 log 2 negative of 10. Okay, so this is the what the value they were asking for. And on calculating it, we are getting the roughly the value as equals to 5.88 Okay. So on this part, for this accuracy part, you will be getting A1, and the approach for this method and all, you will get the score M1, and for this part, you will be getting A1 for the accuracy. Okay. Now in the next part, student, they have asked that use the answer to part B to find the x coordinate of Q. Show your working and give your answer to the significant figures. Okay, this was the C part, students. Now let's move to the D part. So f prime x will be equals to 2 raised to the power x log 2 negative of 10. This was f prime x. In this B part, to find the x coordinate of Q. So we can see here in the B part, we have already find the value of P, that is was equals to ln2. So we need to plug in this f prime x equals to 0 to find the critical point. So f prime x will be equals to 0. So this will gives us 2 raised to the power x log of 2 negative of 10 equals to 0. Further solving will get 2 raised to the power x equals to 10 by log 2. Okay, so from here we can easily calculate the values. So we'll get the value of x equals to, we are getting the value of x equals to 3.84 roughly. So again, what we'll get, this is the approach for which you will get M1 marks, and the accuracy for accuracy you will get even. Okay, so this is how we need to solve this question, students. Okay, we should write every formula and every question formula, and the solution should be in a proper way which they are requiring, because this will only lead you to get score the even or even star marks. So now let's move to the fifth question, students. They have given us a particular equation here, and we need to find the trapezium value. So, okay. So those who don't know that what is the trapezium formula, so okay, okay. So h by 2, 1 plus of, not 1, it will be equals to y1 plus of yn plus of 2 y2 plus of yn negative 1. This is the trapezium formula, student, which you need to memorize it. This is this is the trapezium formula for the integration, students. Okay. Here we can see that the difference between the intervals is already clear with us, that is 0.25. So we will be substituting this value, and the value of h will be equals to 0.25. We can see the difference between the x component of x here, so that is 0.25. Okay. I'm just applying the trapezium formula, student, to find the integration of e raised to the power negative of x square. So on plugging this value here, we are getting the value of 0.2 by 5 by 2 in the bracket y1 plus of yn. Y1 plus of yn is y1 plus of 0.1054 plus of 2 times of this. All values will be from here to here. This all values will be taken into the consideration. So we'll write the value 0.9394 plus of 0.7788 plus of 0.5698 plus of 0.2096. Okay. So this is the trapezium formula to find the integration of a particular function. So on calculating it, what we are getting, student, just we need to write the values here, and then we'll be getting the values. So We are getting the value here, student, equals to 0.855. Okay, that is the rough value, and for this also you will be able to get the, since this is an independent question, so this is how we'll get the marking for this B1, M1 and A1. A1 is for the accuracy part, that is 0.855. M1 is for the approach, means this formula, and B1, since this is an independent question, independent part in the question, so they'll get B1. So this is the sequence of marking from the examiner point of view, I'm telling you. And in the B part, students, what we need to do, we need to find the integration. So we already know that the integration of negative a to a fx component, for fx component, when fx is an even function, when fx is an, here fx is an even function. How we came to know that it is an even function? It's very easy, students. Just what we need to do, e raised to the power negative of x square. Okay, I'm explaining the content here, not the solution. So e raised to the power negative of x square, plug the value of any value of x here, you will get the same component, that is in the format of e raised to the power negative of whatever the values we are plugging in here. So we'll get the same value, that is equals to in this format only. So on plugging the value of f negative of x also, we are getting the value equals to fx. So this is the criteria for even function, student. So since this is an even function, so we know that the integration of an even function within the range of negative a to a, this is the direct formula. So it is equals to 2 cross of fa. Okay, since we have calculated the integration in the above part, that is equals to 0.855, so the value for this integration will be 2 cross of 0.855, that will be equals to 1.71. It's just an integration part, and yeah, that will be equals to 1.7. Now in the second part of the B, they have told, I'll write it here, they have told integration from 0 to 1.5, 0 to 1.5, integration of e raised to the power negative of x square plus of 7 dx. Okay, this is how we need to solve. So yeah, this is the second part of the B part component. Okay, so from 0 to 1.5 integration, I'm distributing it in the part, students. Now again, this will be the from 0 to 1.5. Okay. This we have already calculated this part, the value of the integration in the first part, that was equals to 0.855 plus of this part. If I say so, since it doesn't have any x component, so x component will be getting added here, and the integration will be from 0 to 1.5. This is what we need to do. We need to plug in the values here, so we'll get 7, 1.5 negative of 0, that will be equals to 10.5 and plus of 8.5. So we are getting the value here, students, 11.355, which is our approximate value. Okay, so this is the solution of the second part, 11.355. In this part also, you'll get how you will get scored here. You'll get for M1 for the correct approach, and accuracy part you will be getting scoring as A1 part. Okay, I'm also discussing the marking pattern of as an examiner point of view, so that you can have a clarity of the marking for the questions. Now let's move to the next question, students. Yeah, they have given a certain question of binomial expansion. Even I have solved the questions for binomial expansions of 2021 to 2024, which is the major part, which in which the majority of the students get stuck and feel complicated from their point of view. So I've already made the playlist for binomial expansion and as well. You can have that access on my channel link. So find the first four terms in an ascending power of x of the binomial expansion. Okay, they have given us binomial expansion here. That is 4 by 2 plus of 3x square. This is the function they have provided us. Okay, how we can write this? We can write this as 4, okay, 2 plus of 3x raised to the power negative 2. We have taken the denominator part in the numerator part, so the power is getting the negative sign here. Now for this, what we need to do, O will be written like this as well. In this part, 2 plus of 3x raised to the power negative 2. We'll be taking the 2 common from this bracket. When take 2 common from this bracket, what we'll get? 2 raised to the power negative 2. Because the whole power here, the whole power component here is negative 2. So whatever the common number which we are taking from the bracket will be expressed with the power. The 2 raised to the power negative 2 here in the bracket will get 1 plus of 3x by 2 raised to the power negative 2. Now on solving this part will get equals to 1. So 4 cross of 4 will be 4 cross of 1 by 4 will be equals to 1. This is the 2 raised to the power negative 2 will be 1 by 4. So it will be 1. Now the component we are left here will be 1 plus of 3x raised to 2 by 2 raised to the power negative 2. Okay. So this we have written in the simplest form which they were asking. So this was the A part. You'll get M1, and then for the accuracy, no accuracy part is here in this A part, but for the B part they will be having the accuracy part. We'll come to the B part, student. For B part, they have asked us find the range of values of x for which the expression is valid. So okay, one more thing, student. They have asked us to write each in the simplest form, writing each term in the simplest form. Okay, so this is not yet completed, so we'll expand it here. So we know the expansion of a binomial series, that is 1 plus of x raised to the power n will be equals to 1 plus of nx plus of n cross of n minus 1 by 2 factorial x square. So this is how the series will go on. So we'll expand this here. So we'll get 1 plus of negative of 2 cross of 3x by 2 plus of n cross of n negative 1 will be equals to negative 2 negative 3 upon 2 factorial 3x by 2 whole square. This is how the series will get expanded. So here we'll get 1 negative of 3x plus of okay, plus of 6 by 2 factorial, and here you will get 9x square by 4. Okay, so 9x by 4. So that will be, now I'm taking the approximation sign here. So that will be equals to 1 negative of 3x plus of, on calculating it, we are getting 27x square by 4. Okay, negative of, this is how the series will go on. If we want to write a fourth term as well here, so we can write it as that is n cross of n minus 1 cross of n minus 2 upon 3 factorial into x cube. Okay, so this is the simplest form. Okay, for the B part, student, the range of the value of x for which the expansion is valid, a plus of bx raised to the power n. For this expansion, if the expansion needs to be valid, so it means that bx by of a modulus should be less than n. So this is general criteria, student, for the expression to be valid. So here we can see that the 2 plus of 3x is there in our exponent part, 2a plus of 3x negative of 2. This is the part here. We're taking the different pen for the b part. Yeah. 2 plus of 3x raised to the power negative 2. For this, what we need to do, just plug in this value here, we'll get the values. So bx by a, so 3x by 2 will be modulus of 3x by 2 must be equals to, less than 1. Yeah, it will be 1, student, sorry. Bx by a will be less than 1. So from here we can see that the x will be, modulus of x will be less than 2 by 3. Okay, so for the expansion to be valid, so for the expansion to be valid, the bx by a, modulus of bx by a must be less than 1. So then only the expansion will be valid here. So for this student, for this part you will be getting b1 marks, and for the above part you will be getting the 1 m1 and a1 on the this also could be solved further because it is a modulus function, so it will lie somewhere between negative of 2 by 3 and 2 by 3. Yeah, this is the common condition for modulus of x when we open this part. So the x will lies between negative of 2 by 3 to 2 by 3. Okay, open bracket. So this all will be the range of the values of x. Okay, now let's move to the seventh part. Yeah, the next question, which is seventh question. The function f and g are defined by, we have given a certain functional values here, and we need to, in the first part we need to find the gfe square, writing your answer in the simplest form. So okay, so function fx is given, that is equals to 3 by 2 log of x. So if we plug in e square here in fx, so what we'll get, 3 by 2 log of e square will be equals to 3 by 2 log e cross of. Okay, this is the property of logarithm, so it will be equals to 3 because ln e is equals to 1, so the value will be here 3. You can find the videos of logarithm in my playlist. I have made a separate video on logarithm and the previous year questions of logarithm. So fe square we have found out as 3. Now we need to find gfe square. So we already know that fe square means the value of f, function of f, when plugging e square we are getting 3, so we need to plug the value of fe square in gx. So what we'll get, 4 cross of 3 plus of 3 upon 2 cross of 3 plus of 1. So this will be equals to 15 by 7. So the value of this will be 15 by 7. Now in the second part, student, this was our first part. In the second part, they have asked us to prove that this is the decreasing function. So what we need to do, we just need to differentiate the given function. Gx is given, that is 4x plus of 3 on 2x plus of 1. Okay, so why we are differentiating? The concept is here that if we differentiate the function, if we get that particular differentiated function less than 0, so it means it is a decreasing function. Similarly, if we get the value of the differentiating function as a positive, so it means it is an increasing function. So we'll be differentiating it. So g prime of x will be equals to, okay, first part will be differentiated and the second part will be written like this. So first numerator part here is 4x plus of 3. So the differentiation of numerator will be 4 and denominator will be written as it is negative of 2. Now the differentiation of denominator, the differentiation of denominator is with respect to x, we'll get 2, and numerator will be written as it is 4x plus of 3 by 2x plus of 1 whole square. We have applied the quotient rule here, student, for the differentiation. So here what we'll get, 8x plus of 4 negative of 8x minus of 6 upon 2x plus of 1 whole square. Okay. On further calculating, we'll get g prime of x equals to 4 negative of 6. So this value got here cancelled. So we'll get negative of 2 by x plus of 1 whole square. Okay, now see here, students, that, okay, this is the explanatory part. I'll be explaining it to you here. This is the square function. So whatever the value we'll be inserting it here, we'll get the positive value. Okay, so for this, it will always be a positive value. Okay, now for the numerator part, it is with the negative sign. So the function value means the overall value of g prime x will be negative. Okay, because the denominator will always be positive. So hence we can show here that g prime x is always less than 0. Okay, student. Now coming to the third part, that is C part, we need to find the range of the function fg. Okay, now C parts we are solving here, student. Yeah. C range of fg, they have given fg. Function of x is 3 by 2 log of x. Gx is also given. So function of x is 3 by 2 log of x, and gx is also given. That will be 4x plus of 3 by 2x plus 1, 4x plus of 3 on 2x plus of 1. Now fg, so fg, don't get confused here. Majority of the students get confused that what we need to do here. So we just need to plug in the value of gx in fx. Okay, so for this 3 by 2 log of x, in place of x we need to plug in the value of gx. So we'll get 4x plus of 3 upon 2x plus of 1. Okay, this is the value of fg. Now we need to find the range of this particular fg, but which we have given here. Okay, let's do this part clearly. Okay, 3 by 2 log of 4x plus of 3 upon 2x plus of 1. Okay, this is the function value which we have got as the value as fg. Now see here, we have already proven in the previous slide, student, that g prime x is a decreasing function. This we have already proven on the previous slide, and we also know that function of x is g prime x. We have proven that it is a negative. So wait a second, gx is a decreasing function, which we have already proven. Now function of x, that is 3 by 2 ln x, this is the functional value of x. So we know that it will always be a positive value. So 3 by 2 log of x, this will always be a positive function. This we already know, because this is a logarithmic function, it can't be negative. Means the function fx is a positive function and the function gx is a decreasing function. Okay, so if we want to find the range of this particular value, so what we'll do, that is 3 by 2 log of, okay, first what we need to do, first will be, if we substitute the value of x equals to 0, so what we'll get? Okay, why I'm substituting the value of x equals to 0? This will be also the question. So here we will get 3 by 2 log of 3 if we are substituting x equals to 0. Okay, because the domain of this logarithmic function will lie from 0 to infinity. This is how we can plug in the value of x here. since it is a decreasing function. So this particular argument of log, this particular argument of log, this we are considering. We can't put the value of x less than 0. So we are plugging the value of x equals to 0. So on plugging the value of x equals to 0, we are getting 3. Now in the second part, for the second thing, we need to plug in the value of x equals to infinity, because it will, we know that this is how the graph is made of log. Like this, this is how it is made. It always passes through 0 comma 1. Okay, this is what we know. Now that is why here it is going till infinity. Okay, so argument we are discussing. So we'll plug in the value of x equals to infinity. We will not directly plug in the value. I'll tell you how. 4x plus of 3 is written 4x plus of 3 on 2x plus of 1. Okay, so for this I will explain you here. Most of the students get confused. This what we need to do. Plugging the value as x as infinity, so 4 plus of 3 by x. We are dividing whole by x. Why we are doing this? So that on division by infinity we'll get the value as 0. So 2 plus of 1 by x. Okay, so on plugging it x equals to infinity here, what we'll get? We'll get 4 on the numerator part and 2 on the denominator part. So the remaining value which we'll get here will be 3 by 2 log of 4 by 2. That will be equals to 3 by 2 log of 2. Okay, so for 0 we are getting the value here as 3 by 2 log 3, and for the infinity part we are getting the value as 3 by 2 log of 2. So in both of these value, which is the smaller value, that is 3 by 2 log of 2, so fg will lie between 3 by 2 log of 2 and 3 by 2 log of 3. Okay, one more thing, student, the value of x in both the cases will not be included. For example, we can't take x directly 0 here. Okay, that argument will not be will not have a particular value. It will not be defined, which I've already discussed in my logarithmic series. Similarly, we can't take x equals to infinity directly, because on putting it infinity, our value will get collapsed. The argument will not be justified. So that is why we will be keeping like this. That is the reason we are not taking the inclusion sign here. Okay, this is the exclusion sign, the FG range I have written here. Student, this is how we need to solve this question. Now let's move to the next question, that is very easy. So since they have given us a certain value here, okay, we know that what we'll do, y is equals to root of 2x negative of 7. Okay, from here what we can do, we can directly take the value of x here. How? We'll square both the sides. Y square is equals to 2x plus of 7. Okay, upon, now okay, we have squared both the sides. Now here what we'll get, y square negative of 7 equals to 2x. So x will be here equals to y square negative of 7 upon 2. Okay, what I am doing here, this is the very easier method for the students, easier one. Apart from going into the deep analysis, we can go like this. We all know that the area of a curved portion is given by the x dy integration of x element with respect to dy. Okay, so this is very common, means whatever area we are we need to take the area of a particular function. So this is the general formula. Okay, so x here, student, is y square negative of 7 upon 2. Dy will be written directly, and it lies from 0 to 5. So we'll integrate from 0 to 5. Okay, so yeah, now on calculating it further, just we need to integrate here, students. So what we'll get here, we'll get y cube by 6 negative of 7y by 2 in the bracket. Integration is from 0 to 5. So area, what we'll get here, student, area will get y cube by 6 negative of 7y. We'll plug the value, and plugging value equals to 0, so the all the values will be 0, but on plugging 5 we'll get 5 cube by 6 negative of 7 cross of 5 by 2, that is will be equal to 125 by 6 negative of 35 by 2, which will be equals to 115 by 3. Okay, so this is the area of a sketch, means area of the curve, square units, which we need to write here. So on this, what we will get, this is the approach here. So A1, and the accuracy mark means this is, sorry, you will not score A1 here, you will get score A1 here, student, and this is for this method you will get M1. So this is the marking scheme for this question, that is M1 A1. Even we have certain other ways to find this question, that is the bottom limit and top limit, and then we need to find the full area, and full area will be equals to, we need to take the rectangle negative of the sector angle. So there is also a way, but I will go with this way because this is very easy. This is the general format of area under the comes to 5. Okay, this is the value from 0 to 5. Okay, where x was varying. So now let's move to the next question. Yeah, next question here is that the proof that the difference of the square of two consecutive odd number is always a multiple of 8. Okay, so first part we are doing here, that is square of the two consecutive odd numbers. What will be the odd numbers, student? So odd numbers will be represented by, odd numbers represented by two consecutive odd numbers are represented by 2p plus of 3 and 2p negative of 1. 2p plus of 1, sorry. Now, according in the first part, they have asked that the difference of the square of two consecutive odd numbers. So difference of the square of two consecutive odd numbers. So 2p plus of 3 whole square negative of 2p plus of 1 whole square. We need to calculate this part. So we'll get 4p square plus of 9 plus of 12p negative of 4p square plus of 1 plus of 4p. On calculating it, we are getting this value and this value got cancelled, and 8p plus of 8. So according to the question, they have asked us that whether this is if is the always a multiple of 8. So we can say here, yeah, it is always a multiple of 8, because if we take 8 common in our this value which we have got, so we can see that it is always a multiple of 8 here. Okay, so this is the solution of the first part. For the second part, student, show that the difference of the square of two consecutive number is not always a multiple of 8. Okay, now for this part, okay, since first of all you will score M1, and for the accuracy we'll get A1 here. Okay, for the second part, student, it is a very easy part, and we'll get a B1 for this question. Okay, now what we need to see as an examiner point of view, I'm saying, so it is 1 marks question, so we can apply the format which we have applied ahead. So 2p and 2p plus of 2 could be taken here. Okay, from this also you will get the solution for this question. So difference of the square of two consecutive even number, So 2p plus of 2 whole square negative of 2p square. Okay, once you will solve this, so you will get the value. Okay, you will expand it. So we are getting the value here 4p square plus of 4 plus of 8p negative of 4p square. This and this got cancelled. We are left with 4 plus of 8p. So from here we can say, student, that if we take 4 commons, we will get 1 plus of 2p. Okay, so from here we can say that it is not always a multiple of 8, which we have proven. Now, the thing which I wanted to discuss as an examiner point of view, since you will score B1 here for this part because it is an independent part. Now, for this I was saying, since it is of 1 marks, the other approach could be also taken here. That is, take two consecutive even numbers, like for example 4 is 4 and 2. Now we need to see the square of the two consecutive even numbers. So we'll square it. 4 square negative of 2 square. What we'll get? 16 negative of 4 will be equals to 12. It is not the multiple of 8. So this will also means help you in getting A1 B1 marks. So this way I'll suggest you, students, because it is of only 1 mark. Okay, this is also correct. Don't worry. And this is also correct. Since it is of 1 marks in the examination, we get less time, so we are preferring this method. Okay, now let's move to the next question. Yeah, for this question they have given certain curve equation. Okay, now in the question they have mentioned that it has a maximum turning point at x equals to 1. Okay, what does it mean? So means maximum turning point, so it will be equals to f prime of 1 equals to 0. Why I have directly written here, student? Because they have already mentioned that 1 is a turning point, means it is a critical point where the graph will be turning. So it means the differentiation of that function, we'll be calculating it to find the critical point. So fx is 4x negative of k e raised to the power negative of x square. So we'll apply chain rule here. Even I have made the videos on this part as well, the differentiation part. Most challenging questions of differentiation derivatives have been taken by me, and the playlist is there. And for this part, fx, if we are saying fx is equals to 4x negative of k e raised to the power negative of x square. Okay, what we need to do, we need to first find the derivative of function of x. So what we'll get the chain rule we are following here. So the first part cross of differentiation of second part plus differentiation of first part cross of second part. So whatever function you want to take, you can take. So if I am differentiating the first part here, so we'll get 4. Second part will be written as it is plus of. Now first part will be written as it is for e raised to the power negative of x square. The differentiation will be negative of 2x e raised to the power negative of x square. So here we'll get 4ex e raised to the power negative of x square negative of 2x e raised to the power negative of x square or x negative of k. Now f prime 1 will be equals to 0 because we have discussed this is one of the critical points. So we'll plug in the value here. So we'll get 4 e raised to the power negative 1 plus of 4 negative of k cross of 2. Okay, sorry students, here we'll get here we'll get negative because we have already written here 2 e raised to the power negative 1, that will be equals to 0. Okay, so on further solving it, what we'll get? So we'll be getting 4 e raised to the power negative 1 negative of 8 e raised to the power 1 negative 1 plus of 2e inverse k equals to 0. Okay, so from here we can see that e raised to the power negative 1 is here. So we'll get negative of 2 e raised to the power 1, sorry, 4 e raised to the power negative 1 plus of 2 e raised to the power 1 k equals to 0. So from here what we'll get, the value of k we are getting here, 2 e raised to the power negative 1 k equals to 4 e raised to the power negative 1. This value and this value got cancelled. From here we are getting the value of k is equals to 2. So this is what we need to prove here. Now in the second part they have told that show that the only other turning point is at x equals to negative 1 by 2. Okay, only other turning point. It means, student, that the other critical point is also mentioned here, that is negative 1 by 2. Okay, so we have differentiated our function here, see. Okay, so f prime x, I'm writing it again by plugging the value of k equals to 2. So 4 e raised to the power negative of x square, negative of 2x e raised to the power negative of x square, 4x negative of 2, because k here is 2. Okay, if I take e raised to the power negative of x square common from the expression, so what will left out with? Oh, negative of 2x, 4x negative of 2. On calculating it further, what we'll get? E raised to the power negative of x square, and here we'll get 4 negative of 8x square plus of 4x. Okay, so this is value, this is the value. Still it is not solved, so don't worry. So e raised to the power negative of x square, this will be written as 8x square plus of 4x plus of 4. Okay, now we'll be factorizing it here. Okay, let's move to the next slide, student. F prime x we are getting as e raised to the power negative of x square and minus of negative of 8x square plus of 4x plus of 4. This is the what we are getting the value here. Now on solving it further, we'll be solving it further, students. So we'll be factorizing it, this 8 negative of 8x square plus of 4x plus of 4. So we need to multiply the leading coefficient with the constant term, and then we need to take the prime factorization and make the sum such that it comes 4. This is the factorization method which we'll be applying here. So okay, what we can do more here, we can take the 4 negative 4 common here. So yeah, we can take the negative 4 common here. So we left out with the term 2x square negative of x negative of 1. Now this will be easier for us to factorize. Negative of 4 e raised to the power x square cross of x negative of 1 into 2x negative plus of 1. Okay, so this we have factorized, and this is the value which we are getting, and this is f prime of x. Now they have told us to show that, okay, means the answer is also already there, will be judged on the basis of the methods we are applying it. So f prime x will be equals to 0. So negative of 4 e raised to the power negative of x square x negative of 1 2x plus of 1 is equals to 0. From here we can say, okay, now I'll explain you here, students. This part, if by c. So negative of 4 is a number, so no issue. For this part, exponential part, it can't be equals to 0. So e raised to the power negative of x square can't be equals to 0. This is already given in the question that the one of the turning point was 1 and the other turning point we need to show. So we have already shown here, student, that will be equals to 0. So from here we'll get x equals to negative of 1 by 2, which they have asked us to show. Okay, now let's move to the third part, that is the find the range of the possible values of p when the particular equation fx equals to p, where p is constant, has exactly two distinct roots. Two distinct roots they have told, means we have already got that critical points here. That is the two distinct root. Here you can see that one is at the here is 1, and one of the root we have got as negative of 1 by 2c. So this is 1 and this is negative of 1 by 2. So for this range, we need to find the range of the possible values of p. So those who don't know, that for a graph, if we want to find the range, so we'll take the tracing paper and we can cover from the upside to the graph, and we can see that where it will be, will it be interacting at x equals to 1. This is the logic I'm discussing here, student. If this is a paper, if this is a graph, if this is a any tracing paper which we have taken, and we are covering the graph from the upside, so it will interact at 1. Okay, and similarly we need to do from the downside of the graph, so we can see it will interact at negative of 1 by 2. Those who are not getting the concept of range, for them I'm talking. So we'll take the graph and we keep on moving towards the curve, and whenever that curve get intersected with our tracing paper, that is the point which we are looking for. So this is the point negative of 1 by 2, and one of the point is at 1, x equals to 1. Be sure that it is x we are discussing. So at x equals to 1, okay, and for at x equals to negative 1 by 2. So this value will be plugging it here in the function of x. So we'll be getting f1, whatever the function was, 4x minus of k, 4x4 negative of 2 e raised to the power negative of x square negative of x. So it will be e raised to the power negative of 1. Similarly, f, plugging the value of second critical point, that is negative of 1 by 2. So okay, here the value will be 2 e raised to the power 1 negative 1. For e raised to the for functional value, negative of 1 by 2, what we'll get, o cross of negative of 1 by 2, negative of 2 e raised to the power negative of 1 by 2 whole square will be 1 by 4. So that will be equals to negative of 4 e raised to the power negative of 1 by 4. This is the value. So the range we have already got, student. So this, the function will lie between this p, which they have told that fx was equals to p. It will lie between, students, negative of 4 e raised to the power negative of 1 by 4 and 2 e raised to the power negative of 1. This you can see here that negative function will always be on the left side, and the positive function will always be a right side. So it is not, it is very easier for us to decide because it is with the negative sign, so it will be on the left side, and this is with the positive sign, so it will be on the right side. Okay, students, let's move to the next question, which is the 11th question, which they have asked us to prove with the first principle. So it's very easy, student. So we'll do it. So first I will write the first principle, student. Limit of h tending to 0, fx plus of h negative of fx is equals to f. Okay, sorry, h. So this is the, yeah, this is the first principle. Okay, so we need to, from the first principle, the derivative of the sine theta is cos theta. So, okay, so let's say uh, limit of h tending to 0. This is the derivation of sine theta we are calculating here, d by dx of sine x, limit of h tending to 0. So on plugging the value of fx plus of h, okay, function of x here is sine x, student. So function of x plus of h will be sine of x plus of h. Okay. So fx plus of h. Now plug the values in the first principle. We'll be getting sine of x plus of h, negative of sine of x upon h. Okay. On calculating it further, we'll get limit of h tending to 0. Now open this with the trigonometric identity. Sine x plus of h will be equals to sine x cos h plus of cos x sin h. Negative of sin x is already mentioned there, sin x upon h. Okay. Okay. Now, on further calculating, what we can see here, limit of h tending to 0, we'll take sin x common here in this and this part. So we'll left out with the cos h negative of 1 plus of cos x sin h upon h. Okay. On segregating this function, what we'll get? We'll get limit of h tending to 0 sin x. I'm just segregating it, students. Cos h negative 1 upon h plus of cos x sin h by h by h. Now we can see here, students, that this part is given as 0 in the question. So this will be equals to 0, and this part is equals to 1 because it is also given in the question. See, sin h by h is equal to 1. So the solution, final solution will be, unplugging the value of h equals to 0, we are getting the value here cos h. So this we need to prove. We have already proven this part. D by dx of sin x is equals to cos x. Cos x, not h, sorry. So this is how we need to prove. Okay, now let's discuss about the marking scheme. So here you'll be getting m1 mark, and since this is an independent question, so we'll be getting firstly b1, then we'll get m1 mark for the method we are applying, and even we'll get for the accuracy part, we'll be getting a1 here. Okay, so this is the strategy of giving the marks to student, which we are discussing with nearly every question we have discussed. So let's move ahead. Yeah, next question is of vector, students. Means they have given a certain cuboid here and we need to find the values here. So okay, so yeah, OA is equals to 4i, OC is equals to 3j, and OD is equals to 2k. Okay. Okay. See, in the second statement, they have mentioned that M and N are the midpoint of AB and CG respectively. So M is the midpoint of AB, and so AB. Since OC is equals to AB, OC is equals to AB. It is already visible to us. So what we can say here, that this value will be also equals to 3j. Okay, and N is the midpoint of CG. Yeah, this is CG. So that will be equals to, this part will be equals to 2k. Okay. Now what we'll do, I'm just making a rough diagram for you. So we'll join OM here. Okay. OM, OM. So OM vector will be equals to, let's see this triangle, students. Yeah, I'll be drawing it again, I'll be erasing it again. So in this part, AM we can say easily that it will be equals to 3j by 2. Okay. In the triangle OAM, OM will be equals to OA vector less of AM vector. This is visible here. Okay. So OA vector is here 4i plus of AM vector we have calculated as 3j by 2. OM vector we have got. Now come to the N part. See, I'm drawing the rough diagram here. See. So in the triangle OCN, OM vector we have calculated 4i plus of 3j2. Now for OCN, what will be the value of CN? CN will be equals to 2k by 2, since n is the midpoint of CG, and we have already observed that the value of CG is 2k, so CN will be k, so it will be k. OC vector CN will be 1, not this part, so it will be k vector. So OC vector will be 3j. Okay, so in the triangle OCN, we can say that ON vector will be equals to OC vector plus of CN vector. So ON vector we need to calculate. So OC is here 3j plus of CN, that is k. Okay, so we have got the value of ON and OM. These are the major vectors which we need to find. So OM vector we have already got. Okay. So OM is equals to 4i plus of 3j by 2, and ON is equals to 3j plus of k. Now if I say what will be the value of MN vector, see in this diagram only, what will be the value of MN vector? MN. So in the triangle, yeah. Now if you are able to visualize this part, that in the triangle OMN, in the triangle OMN, in the triangle OMN, what will be the value of MN? MN vector will be equals to, if you are able to visualize it, we can see here that MN vector will be equals to ON vector negative of OM vector. See, this was the value which we have calculated in the triangle OCN, and in the triangle OM we have calculated in the triangle OAM. In the triangle OAM we have calculated the OM vector. Now we need to calculate the value of MN vector. So from here we can see that ON vector we have got the value and OM vector we have got the value. So MN vector, what will be the value of MN vector? So MN vector will be equals to ON vector negative of OM vector. Okay, since we require the direction of MN vector, so this is why I'm doing like this. Students, don't get confused. Okay. We are applying the triangle law of vector addition. So MN will be equals to ON negative of OM vector. Okay, we can see the direction here from N to O, the direction will be going from N to O, then from O to M, then from M to N. So we need to reverse the sign to justify it. So Mn vector will be equals to On vector. On vector will be 3j plus of k negative of Om vector, that will be equals to 4i plus of 3j by 2. Now here we can see that Mn vector we will be able to calculate here. We'll be getting negative of 4i component vector and plus of 3j by 2 plus of k. This is the value of Mn vector, students. Okay, Mn we have calculated. Now let's come to this part. OP, we need to show it. Means we'll be getting the value, means we'll be getting on the method and approach. Okay, on the accuracy, and the value, the final value is already given here. Okay, in the question, student, they have told that MP is equals to 3 times of Pn. P is certain point lying on the Mn. Okay. So MP is equals to 3 times of Pn. Okay. So why can't we say that MP will be equals to 3 by 4 times of Mn vector? How we can say it? Okay, since P is the point lying on the Mn, I will be writing it here, students. MP vector plus of Pn vector will be equals to Mn. Okay, I'm justifying it here. MP is already given equal 3Pn, so 3Pn we are writing plus of Pn is equals to Mn. So from here we can see that Pn vector is equals to 1 by 4 times of Mn vector. Okay, so since we have got Pn vector, so we will plug this value here. So what we'll get, MP vector will be equals to 3 by 4 times of Mn vector. So if I calculate it further, we'll get 3 by 4 of Mn vector. Mn vector is negative of 4i plus of 3j by 2 plus of k vector. That will be equals to negative of 3i plus of 9 by 8, yeah, plus of 9 by 8 j plus of 3 by 4k. Okay, this is the value of MP vector, students, whatever the point here is, MP vector. Okay, I'll be joining it here, so don't get confused here, student. I have taken certain point here in P vector. Yeah, so in the triangle OMP, if you are able to visualize it, in the triangle OMP, what will be the value of OP vector? See, OP vector will be equals to OM vector plus of MP vector. OP vector, triangle law of vector addition I'm doing, students. OP vector will be equals to OM vector plus of MP vector. So, okay, in the triangle OMP, this is only for the visualization, students. It will be easier for you if you will draw the triangles in this case. So it will be more easier for you. So in the triangle OMP, OP vector will be equals to OM vector plus of MP vector. Okay. So OM vector, what we have calculated here. Okay. OM we have calculated 4i plus of 3j by 2. 4i plus of 3j by 2 plus of MP vector, we have calculated it as negative of 3i plus of 9 by 8j, negative of 3i plus of 9 by 8j plus of 3 by 4k plus of 3 by 4k. Okay, So on solving it, we are getting the value of I OP vector as I plus of 21 by 8j plus of 3 by 4k. Okay, we will calculate by taking the like coefficients. This we are not getting the point, so that is why I have described it here. The OP vector, we were able to show that OP vector is equals to I plus of 21 by 8j plus of 3 by 4k. Okay. Now in the next part, student, they have told that a straight line through O and P meets the face BFGC at the point Q. At the point Q, find the coordinate of Q. BFGC is the face which is here. Here's the BFGC. This is the face. Certain point is there, Q point. Okay. So if I say, I will not draw the diagram here. If I say for OQ vector, just means if you are able to visualize it for a OQ vector, what will be the component? Okay, first of all, see, since we have got the value of OP vector equals to I vector plus of 21 by 8j plus of 3 by 4k. Okay, OQ vector we need to calculate. It is in the same direction of OP vector, so it is a component of a OP vector, means lambda is a scalar quantity here. So this is the property of vectors who don't know this thing. So OQ vector will be equals to lambda times of OP vector. Now come to this part again, the diagram which I was showing you. From O to Q, which main component will remain same? Okay, so we can easily say that x and z coordinate will be varying, but y component will remain same. Okay, think again, that y, x and z coordinate will vary, not the y component. Okay, because from O to P we are going in the y direction. Similarly, from O to Q, this is the same direction. OQ is some scalar, means some product of scalar quantity with the OP, but x and z component will vary here. Okay, yeah, so OQ is equals to lambda times of OP. Okay, see here, students, in the question, that if I say that OP and OQ both are the same component and of y, okay, only x and z component of this vector will vary. So the y component here is 3j. Okay, so OQ will be equals to, OQ vector will be equals to lambda times of OP vector. So it will be I plus of 21 by 8j plus of 3 by 4k. Now, why I'm saying this part, that only y coordinate will be, y component of this vector will be same, and OQ will be equals to some scalar quantity times of OP vector, because it is in the same direction. So OP component, the value of the OP component which is in the y direction, so it is 3j vector. So for y component, (21 by 8) lambda times of j will be equals to 3 times of the j component of OP. Okay, from here what we can get, the value of lambda equals to 8 by 7. Okay, now what we need to do, we will be plugging this value here. So OQ vector will be equals to 8 by 7 I plus of 21 by 8 j plus of 3 by 4 k. Okay, this is not the final solution yet, student. We'll be doing it. Plus of 3j plus of 24, 6 by 7, sorry, 6 by 7 k. So this is the O coordinate, OQ vector. From here, what will be the coordinate of Q? Coordinate of Q will be 8 by 7. The x component is 8 by 7, y component is 3, and the z component is 6 by 7. So this is the coordinate of Q, student. Okay, this is our final solution. For this step, we'll get M1 for the method, and this for this accuracy we'll get A1. Okay. Similarly, for this part also we'll be getting M1 and A1 for the B1 which we have calculated. And the first part, the method we are applying to show the component of OP vector. So this is how this marking scheme of this question will work. Now let's come to the 13th question, student. In the 13th question, they have given a 3 terms of a geometric sequence. So we know what is geometric sequence, how it progress ahead. So those who don't know, so I'll be doing it here. So it is the geometric sequence. This is how the sequence will move on. Now the second component here is 3 sine by 2 theta. First component is 8 sine theta. So I'll write it here only. This is A, this is AR, this is AR square. So from here what we can say that AR by A will always be equals to AR square by AR. Okay, means second component by first term will be equals to the third term by second term. The common ratio will be same. So second term here will be 3 sine 2 theta upon 8 sine theta will be equals to 2 plus of 2 cos 2 theta upon 3 sine 2 theta. Okay. Okay. If we cross multiply it, what we'll get? We'll get 9 sine 2 theta sine square 2 theta. So we can write this part as, okay, we are cross multiplying it, student. Yeah, I'll do it again. 3 sine 2 theta whole square will be equals to 2 plus of 2 cos theta cross of 8 sine theta. Okay, so for this 2 plus of 2 cos theta, 2 plus of 2 cos theta, yeah. So here what we'll get, 9 sine square 2 theta, 9 sine square 2 theta will be equals to 2. If we are taking commons, we'll left out with 1 plus of 2 cos theta. 1 plus of cos 2 theta will be equals to 2 cos square theta cross of 8 sine theta. Okay, 8 sine theta. This is the value which we are getting here. Now if I solve it further, so what we can write it here, 9 sine 2 theta, it will be equals to 2 sine theta cos theta whole square will be equals to 4 times of cos square theta cross of 8 sine theta. Now again, if we are doing it, so 9 cross of 2 sine theta cos theta, this whole square will be 4 times of sine square theta cos square theta, that will be equals to 4 times of cos square theta cross of 8 sine theta. Okay, so from here we can say this cos square theta and this cos square theta got cancelled. This 4 and this 4 got cancelled. So we are left out with the term 9 sine square theta equals to 8 times of sine theta. Okay, So majority of the students, even I also did wrong here. We don't cancel like this the component here. So what they will do, they will directly cancel this out. It is okay, but the method which could be done here, that is 9 sine square theta negative of 8 sine theta. So from here we what we'll get, we'll take sine theta as common. So we're left out with 9 sine theta negative of 8 equals to 0. So for this, if I say, I will do it here. So sine theta will be equals to 0 and sine theta will be equals to 8 by 9, which we need to prove. So this is the question they have asked for. Okay, why this value will not work, student? Why this value will not work? They have given the angle here that theta is lying between 0 to pi by 2, and it can't be equal to 0 because it is excluded here. So this will work here. So sine theta will be equals to 8 by 9. Okay. Now if I say prove that S infinity exists. Now we need to prove that S infinity is existing. Okay. So how you will prove it? Sine theta. Okay. We'll plug in the values here. See what I'll do. The first component was 8 sine theta. 8 sine theta. The second component was 3 sine 2 theta. The third component is 2 plus of 2 cos 2 theta. Okay. We have got the value of sine theta equals to 8 by 9. So sine theta is equals to 8 by 9. If we apply the identity here, students, so what we'll get? Sine square theta plus of cos square theta is equals to 1. So from here 64 by 9, 81 plus of cos square theta will be equals to 1. From here what we'll get, cos square theta equals to 81 negative of 64 by 81. So this we are getting as yeah 181 negative of 64 by 81. So this we are getting as 21 by 81 if I am not mistaken. Sorry, not 21. It will be 6 plus of 10 is 16, 17 by 18. Sorry, 17 by 81. This is the value which we are getting here. So for cos theta, it will be root times of 17 by 9 plus minus 9. Okay, why we have done this? I want to show you here something like okay, 8 times of sine theta, it will be 8 cross of 8 by 9. For 3 times of sine 2 theta, it will be 2 sine theta cos theta. We'll plug the value here, will not take the third term. So for second term, 3 times of 2 times of sine theta, that is will be equal to 8 by 9 cross of cos theta, that is equals to 17 by 9. Okay, so we can see here, students, we need to find the r component, second term by first term. So it will be 6 cross of 8 by 9 cross of root 17 by 9 upon 8 times of 8 by 9. Here this got cancelled. So we can see here that 3 by 4 cross of root 17 by 9. Okay, so we need to find the value of this particular equation. So of this particular value of r. So if we are calculating it, the value of r will be 3 cross of root of 17 upon that is coming as 0.343. Okay, so from here we can see that the R component is less than 1. Okay, so we know that if R component is less than 1, it means that sum of infinite term will exist. Okay, even I have made the playlist for the sequences and series chapter, the challenge in questions I have taken here. So R is less than 1, so it means S infinity will exist, which I have written here. Now in the find the value of C part, S infinity negative of S10, giving your answer to the two significant figures, students. Okay, so S infinity will be equals to A by 1 negative of R. What will be A here? A here will be 64 by 9 upon 1 negative of 0.343. Okay, if you want to calculate, you can calculate it here, but I'll not go ahead with this part. I'll be keeping it on hold here. For S10, S10's 10th term, the sum of the 10th term will be, how we calculate it? It is given by A 1 negative of R raised to the power 10 upon 1 negative of R. A is 64 by 9 and 1 negative of R raised to the power 10, 0.34 raised to the power 10 upon 1 negative of 0.34. Okay, so S infinity negative of S10. So from here, what we need to get? S infinity negative of S10, we'll be calculating it. We'll just solve this value S infinity and S10 from here, and then we can plug in the values. So we are getting the values in decimal point, that is 0 point of something between 0.00025, which could be written as 2.5 cross of 10 raised to the power negative 4. Okay, this is the rough answer which I have calculated here. Okay, this is the sum of the 10 terms. This is for S infinity. In the question they have asked for S infinity negative of S10. So we need to subtract this value. We'll be taking the help of the calculator, and this is what we are getting. Okay, for the same we'll be getting marks for the approaching for this with M1, and for accuracy we'll be getting A1. Same goes for the other parts as well. This part will be for this also, the method will be M1, and for the approach for the accuracy we'll be getting A1. Okay, students, for S infinity, for this part we'll be getting B1 because this is an independent part. Okay, now let's move to the next question, that is the 14th question. The height of the tide they have given mentioned in the question. In the question they have given us a differential equation. Okay, study this part. The largest value of this rate of the change is 2 meters per hour. Okay, so largest rate of the change is 2 meter. So dH by dt will be maximum. When it will be maximum? When, okay, this cos value, the maximum value of cos will be 1. So it will be maximum when the cos component will be 1. So it will be A cross of 1. So it is given in the question that it is equals to 2. So A is equals to 2. We have got the value of A is equals to 2. Okay, now in the second part they have told the time between consecutive tides of a maximum height in the harbor is 12 hours. Okay, the time between consecutive tides of a maximum height. Okay, so this is the cos component. I will not draw the whole thing here. Okay, this is how the cos component graph will be looking like. So the distance between the two tides, okay, the distance between the two consecutive tides. So this is the distance between the two consecutive tides, that is 12 hours. So it is related to the time period, student. So we know that the cos theta, what is the period for this cos theta? That is equals to 2 pi. If we are having certain component here, so let's say bx plus of a component, so we'll be getting as 2 pi by b. This is the time period concept which we are discussing here. Here it is given a cos bt. So the time period for this will be 2 pi by b, okay, for this function. And in the question they have mentioned that this value will be equals to 12 hours. So it will be equals to 12 hours. From here what we can say, the value of b will be pi by 6. Okay. So we have got the value of b equals to pi by 6. A we have already got, that is 2. B we have got pi by 6. Okay. So if we deduce this equation, means if we write it again, so we'll get A, that is 2 cos bt cos pi by 6 cos of t. Okay, this is the whole equation which you'll be getting after deducing this value. Okay, now in the question they have told that the maximum height of the tide in the harbor is 30 by 5 meters. Okay, means h component they are asking about, and we have got the value of the derivative of the h component. What we need to do, we will be integrating here. So dh by dt is equals to a times of cos bt. What will be the integration of this part? If we are integrating it, we'll get a by b sine times of bt plus of c. Okay, this is the component which we'll be getting after the integration of dh by dt. So h here, students, okay, h will be equals to a by b. A we have calculated 2 and b we have calculated as pi by 6 sine times of pi by 6 cross of t. So here we'll be getting pi by 6 t plus of c. Okay. Now if I say in the question they have told, okay, okay, if we deduce it further, we'll be getting 12 by pi sine of pi by 6t plus of c. Okay. In the question they have told the maximum height of the tide was 30 by pi. So h component is given here. So h component is 30 by pi equals to 12 by pi, 12 by pi. Now in the question they have mentioned that this is the maximum of height of the tide. So when will be the maximum height of the tide, students? When this component will be equals to 1. The maximum value of sine will be 1. Then only the maximum height of this tide is possible. So plus of c, that sine component is 1. From here we can say that the value of c here will be 18 by pi. So what is the original equation which we'll be getting here? That is h equals to 12 by pi sine of pi by 6t plus of 18 by pi. Okay, this is the final solution, complete equation for the model. Okay. Okay, students. So this is how we need to solve this question. Now, okay, students, let's come to the 15 number question that has given us a certain model for number of mice in thousands, and they have given a certain equation for the same. So where k is constant and t is the numbers of years after monitoring began. So what we need to do, find a complete equation for this model. Okay, so just read this second statement. In a simple model, the number of mice x in thousands is modeled by the equation. And even they have told us in the first equation that when monitoring began, there were 4,000 mice on the island. So means when the monitoring began, so means t at that time will be 0. And since the number of mice is in thousands, so we'll be taking x equals to 4 instead of keeping it as 4,000. Now plugging this value here in this given model, so what we'll get? We'll get 4 equals to k times of 3 cross 0 will be 0, so we'll be left out with 2 on the numerator part, and in the denominator will be 5. So from here what we'll get, k equals to 10. Okay, so in this case the complete model for this complete equation for this model will be x equals to 10 3t plus of 2 upon 4t plus of 5. Okay, in the second part they do asked us that calculate the long-term population of mice predicted by this model. Okay, so I'll be explaining you this part. This is just for explanation, student. So long-term population, so what will be the time here? The time should be taken as infinity. So we know that if we multiply this all means the numerator and denominator, means if we directly plug in the value of t as infinity, the numerator and denominator will be equals to infinity, so we'll not get any value. So what is better to do, we'll divide it by infinity. Okay, so first we'll divide it by t and then we'll plug in the value of t equals to infinity. So here what we'll get, 10 3 plus of 2 by t upon 4 plus of 5 by t. Okay, so we have divided this numerator and denominator by t. Why we did this? Because if we plug the value of t infinity here, so this value will be 0 and this value will also be a 0. So what will the value of x will be for the long-term population? It will be 10 cross of 3 by 4. It will be equals to 7.5. So in terms of 1000, if I say, so it will be 7500. Okay, so this is the long-term population. Now in the second model, they have told that number of mice x in 1000 is modeled by the differential equation. They have given a certain differential equation where t is the numbers of years after monitoring begins. Okay, so let's do it. This, they have given us 4 dx by dt equals to 6x negative x square. Okay, so if we rearrange this equation, it will be dx by 6x negative of x square equals to dt. Here 4 is left. Okay, so we are left out with 4 upon 6 negative of x. I've taken x common in the denominator part, so we'll left out with this part, 4 by x 6 negative x in the denominator equals to dt. So they have asked in the C part to write this in a partial fraction form. So yeah, so we have got this equation after rearranging. So now we need to write it in a partial fraction form. So what we'll do, we'll apply that partial fraction form for here, so that we'll be taking a by x plus of b by 6 negative of x. Okay, since the denominator of this equation is in the linear format, so we are taking a and b. If one linear equation is there and one linear expression is there and one quadratic expression is there, so we would be taking that a by x plus of bx plus of c. So there are different criteria for taking the equations in the partial fraction form. So since they both are linear in the denominator, so we'll be taking it as a by x plus of b by 6 negative of x. Now what we'll do, we'll multiply here So, okay, 4 by 4 by x cross of 6 negative of x is equals to a by x plus of b by 6 negative of x. So what we'll do, we'll take the LCM on the right hand side. So on the LCM on the right hand side, we'll left out with x 6 negative of x in the denominator, but in the denominator part, a cross of 6 negative of x plus of b cross of x. Okay, now the denominator got cancelled, so we are left with 4 on the left hand side and this particular expression on the right hand side. O equals to 6a negative of ax plus of bx. Okay, now what we'll do, we'll make the coefficients equal. So you can see here that on the left hand side we have 4 and on the right hand side we have particular expression. So since on the left hand side there is no x component, so negative of ax plus of bx will be equals to 0. From here we will get a equals to b. We are making the coefficients equal here, students. Now in the right hand side we have the term 6a, which will be equals to 4 because they are both are constant terms. So from here we can say a is equals to 4 by 6, that will be equals to 2 by 3. Okay, now we'll plug the values of a and b, which will be equal in nature, in this particular equation. So we'll get 2 by 3 x. Instead of a, I have written 2 by 3. Similarly, we'll be writing 2 by 3 6 negative of x. Okay, will be equals to t dt as per the see here it is here. We have rearranged this format, so we'll be taking dt. Okay, now what we need to do, will be integrating it. So now integrating both the sides, so we'll get out 2 by 3 log of x plus of 2 by 3 log of 6 negative of x. There is one mistake, students. See that the sign here will be negative. Why is this so? Because the x argument, in the argument of log 6 negative of x is with the negative signs, so the sign here will be negative. Okay, so I'll be making it as negative, equals to t plus of c. Okay, the integration of dt will be t and c is the constant term which we add on using integration. So on the left hand side, what we'll get, 2 by 3 log of x by 6 negative of x, applying the properties of log. I've made a separate video on the same. Okay, now what we'll do, 2 by 3, so we'll cross multiply 2 by 3 to the right hand side. So we'll left out with log of x 6 negative of x equals to 3 by 2 t plus of 3 by 2 c. Okay, now we can see here, we can see in this equation that c is the constant which should be added and we don't know the value. Now what we need to do here, we will go on the basic model, basic statements. First two statements that was written here, that when monitoring began there were 4,000 mice. So we'll use this part to get the value of c. So we'll take x equals to 4 and t equals to 0. Okay, to get the value of constant c. So if we plug in the value of x 4 and t equals to 0 in the above equation, we'll get log of, here we'll get 2 equals to, this component will be 0, so we'll left out with 3 by 2 c. So C will be equals to 2 by 3 log of 2. Okay, this we have got the constant value C. Now what we can do, we can insert this value here. So we'll get 2 by 3 log of x by 6 negative of x equals to t positive 2 by 3 log of 2. Again, we'll take 2 by 3 log of 2 on the left hand side. So what we'll get, 2 by 3 log of x by 6 negative of x, negative of 2 by 3 log of 2 equals to t. If I take 2 by 3 common here, we are left out with the term log of x, 6 negative of x, negative of log of 2 equals to t. Now again we'll apply the quotient law here, logarithmic properties. So we'll get 2 by 3 log of x by 2 cross of 6 negative of x equals to t. We'll multiply 2 by 3 to the right hand side. So it will become 3t by 2. On the left hand side, it will be log of x 2 times of 6 negative of x equals to 3t by 2. Here what we'll get, x equals to 12 negative of 2x equals to e raised to the power 3t by 2. What I have done, I have taken this log, converted this log into the exponential format. Again, we'll cross multiply here. So we'll get 12 negative of 2x cross of e raised to the power 3t by 2. X equals to 12 e raised to the power 3t by 2 negative of 2x e raised to the power 3t by 2. We'll take the x component on the left hand side. So what we'll left out with x, if we are taking as common, so we'll get 1 plus of 2 e raised to the power 3t by 2 equals to 12 e raised to the power 3t by 2. Okay, so from here we can see, okay, so from here what we can see that we'll be dividing whole expression, we'll dividing this expression on the right hand side. So we can observe here that the equation what we are getting is same to this part. Okay, so from here we can see here. Now from here will be, from this part will be carried on to the denominator part of the right hand side. So we left out with the x equals to 12 e raised to the power 3 by 2t upon 1 plus of 2 e raised to the power 3 by 2t, which is the desired value they have asked for. This is the D part which we have completed. In the E part, hence find the long-term population of the mice predicted by the second model. Students, as I have told you that we need to divide it by the term which we are getting as infinity, because if we are dividing the term which is getting infinity in the equation, so it will be easier for us to get the zero value. So here if we are plugging it directly the value of t equals to infinity in this particular equation, so we'll not be able to find any value. So what we'll do, we'll divide whole expression by e raised to the power 3 by 2t. So if we divide numerator and denominator by e raised to the power 3 by 2t, so what we'll get? In the numerator we'll get 12, in the denominator we'll get 2. Okay, why is this so? Actually, if we are dividing e raised to the power 3 by 2t in the numerator, so this will become 1. Okay, but here in the denominator, 1 by e raised to the power 3 by 2t will be there. On plugging value of t equals to infinity, so that particular value will be 0. So only we left out with the 2, because we are having the coefficient of 2 as e raised to the power 3 by 2t. So here the value which we are getting as the final is 6000. Okay, 6000 is the long-term population of mice predicted by the second model. Okay, now let's move to the last question of this paper. Okay, they have given us a particular sketch of the curve with parametric equation, that is x, and even they have told us the value also, that the value of x they have given. Now point P, where k is a negative constant, lies on the curve. So this point lies on the curve. It means that this point will satisfy this equation, the coordinates. So x here is 4. So we'll directly plug in the values here. 4 equals to 2 plus of 4 cos t. Okay, because that point is lying on the curve, it means that the coordinates of the point P will satisfy the parametric equation which is given. So for x, the value of x here is 4. So we are taking the value of x4, and when we are plugging in parametric equation of x, so here we'll get 2 equals to 4 cos t. Okay, now from here we'll get 2 by 4 equals to cos t. So cos t will be equals to 1 by 2. Now come again to this part. They have mentioned us the range also. So in this range, we need to figure it out that where this cos t will lie. So we can see that t will be equals to negative of pi by 3. Majority of the students get confused here, and they directly plug in the value of positive pi by 3 instead of positive pi by 6 instead of negative pi by 3. So the value of t will be negative of pi by 3. Okay, we need to take care of the range which is given in the question. So t is negative of pi by 3. Now even k will also satisfy this parametric equation. So k will be equals to 3t. Now in place of t, we'll be plugging negative of pi by 3 plus of 2 sine t, sine negative of pi by 3. It will be equals to negative of pi, negative of 2 cross of sine negative pi by 3 will be equals to negative of root 3 by 2. So it will be equals to negative of 3 root 3 by 2. This 2 and this 2 got cancelled. We'll be left out with negative of pi, negative of root 3. This is the k, value of k. So this is how you will, means for method, you will get m1 here. For accuracy, you will be getting a1 here. Okay. This should be the method which should be applied here. And the second part, in the sub part, they have told that point Q lies on the curve, given that the gradient of the curve at Q is negative 3 by 2. Okay. The gradient of the curve is negative 3 by 2. Okay, what does it mean by gradient? So we know it is the dy by dx was a slope format. So they have given us negative of 3 by 2. Now come to the parametric equation. In the y and x both component, on the left part we can say that it is the parametric equation in the terms of t. So dy by dt we need to calculate. So dy by dt will be equals to 3. We are differentiating y with respect to t, and here we will get cos t. Similarly, dx by dt, even I have made a special series for the concept of differentiations. You can find that too in my channel links, and dx by dt will be The differentiation of constant will be 0. For this, it will be negative of 4 sine t. From here, we can say that dy by dx dt upon dx by dt will be equals to dy by dx. So, dy by dx. What we need to do here, we need to divide it. Okay, so let's divide it. So it will be 3 plus of 4 cos t upon 3 plus of 2 cos t, not 4 cos t, 3 plus of 2 cos t upon negative of 4 sin t, negative of 4 sin t will be equals to dy by dx. Okay, in the question they have told the dy by dx value is negative 3 by 2. So we'll plug in the value here. So we'll get out 3 plus of 2 cos t equals to negative of upon 4 sin t equals to negative of 3 by 2. Okay. From here we can see that this 2 and this 2 got cancelled, negative sign and negative sign get cancelled. We left out with 3 plus of 2 cos t equals to 6 sin t. Okay, what we can do here, we have different method to find t, because in the second part, in the last part, they have asked us to find the value of t at q, giving your answer to 3 significant figures. I'll choose the easier one for you. Okay, from here what we can do, we'll just square on both the sides. So we'll get 3 plus of 2 cos t whole square equals to 6 sin t whole square. So we'll get 9 plus of 4 cos square t plus of 12 cos t equals to 36 sin square t. Okay, this is the simplest form which I'm discussing here. Okay, 9 plus of 4 cos square t plus of 12 cos t will be equals to 36. Now we'll apply that identity sin theta plus of cos theta, sin square theta plus of cos square theta equals to 1. So from here we can say that sin square t could be written as 1 negative of cos square t, and 9 plus of 4 cos square t plus of 36 cos square t plus of 12 cos t equals to 36. On simplifying it, we are getting 40 cos square t plus of 12 cos t negative of 27 equals to 0. Now from here we can see that it is the quadratic equation in cos t format. Okay, so if we apply the quadratic equation formula, it is minus plus b plus minus of the square root b square negative of 4ac upon 2a. So we'll be applying this quadratic equation formula here. So what we'll get, cos t is equals to negative of 3 plus of and plus minus of under root b square minus of 4ac. So b here is negative 12. I'll be plugging the values first, then you will be able to get what I'm doing. Negative of b plus minus of under root of b square will be 12 square, negative of 4 cross 40 cross of negative 27 upon 2a 2 cross of 40. Okay, so on solving this part we are getting, okay, so we'll be getting a particular values here, student. 144 here we'll be getting 12 negative of 12 itself plus minus of 144 negative of plus of 4 cross of 40 cross of 27 4320 upon 80. Okay, so from here we'll get a particular value here, students, that we are getting here. if we take the values here, we can directly simplify this equation and then we can get. So I'll be writing the values here. After taking the inverse here, we are getting t equals to 0.816. Okay, just solve this equation, then you'll be getting this value. Okay, we'll be taking the inverse of cos inverse on the right hand side, and t will be equals to 0.816. Okay, students, so this was the last question of this test paper, and we'll be coming with the more challenging topics and more question papers. Stay tuned and be connected with our channel, and you can share this with your friends as well. Hope you like my videos. Thank you.